Taipei, 101. In one of the most earthquake and typhoon-prone regions on Earth, this 508-meter giant faces forces strong enough to snap steel. Hidden inside Taipei, 101 is a 660-ton steel sphere, a tuned mass damper. When the building sways, this massive pendulum moves in the opposite direction, canceling dangerous vibrations in real time. During typhoons and earthquakes, the damper can reduce building movement by up to 40%, protecting both the structure and the people inside. The tower's step design breaks wind flow, and its flexible core allows controlled movement instead of resistance. Shanghai Tower. Rising 632 meters with 128 floors, Shanghai Tower is the tallest building in China, built in a city hit by strong typhoons every year. Its entire structure twists 120 degrees from bottom to top. That rotation reduces wind loads by 24%, cutting structural stress and saving over 25,000 tons of steel. Inside, a double-skin facade creates 9 vertical zones, like stacked cities. This design improves insulation and reduces energy consumption by nearly 21%. Burj Khalifa Tower. This is the tallest building on Earth. At 828 meters tall, with 163 floors, Burj Khalifa faces extreme wind forces at heights where storms behave very differently. Its secret is the buttressed core system. 3 wings surround a massive hexagonal core, bracing each other like a tripod, distributing loads evenly in all directions. The building steps back as it rises, constantly changing its shape. The tower uses over 330,000 cubic meters of concrete, 39,000 tons of steel, and can sway up to 1.5 meters at the top, safely. One World Trade Center. Standing 541 meters tall, One World Trade Center rises with 104 floors, built as both a landmark and a fortress. At its core lies a reinforced concrete spine, with walls up to 1 meter thick, far stronger than typical steel frame skyscrapers. Stairwells are pressurized and extra wide, emergency systems are hardened, and the base can resist massive impact forces far beyond standard building codes. The tower uses over 180,000 tons of steel, can withstand winds exceeding 200 kilometers per hour, and is engineered for progressive collapse resistance. John Hancock Center, completed in 1969. The John Hancock Center rises 344 meters tall with 100 floors, standing strong against Chicago's extreme winds. Its secret is external X-bracing, a structural system that moves most of the load to the outside, allowing the building to resist wind forces far more efficiently. This design reduces steel usage by nearly 30% compared to conventional skyscrapers, while keeping sway within safe limits, even during storms exceeding 160 kilometers per hour. The stiff exterior frame allows larger interior spaces, less internal columns, and controlled movement instead of rigid resistance. Petronas Towers. Rising 452 meters with 88 floors, the Petronas Towers once held the title of the world's tallest buildings, in a region with soft ground and seismic risk. The famous Sky Bridge, located at floors 41 and 42, isn't rigidly fixed. It's designed to slide up to 25 millimeters at each end, allowing both towers to move independently during wind or earthquakes. Instead of steel, the towers use high-strength reinforced concrete, weighing over 300,000 tons, ideal for Malaysia's soil conditions and vibration control. A multi-tube structural system limits sway to under 1.5 meters at the top, even during strong tropical storms. 30 St. Mary Axe. Completed in 2003, 30 St. Mary Axe rises 180 meters tall with 41 floors, right in the heart of London's dense urban core. Its structure is a diagrid system, a diagonal steel lattice that carries both gravity and wind loads. The curved shape minimizes wind turbulence, while 6 spiraling ventilation shafts allow natural airflow every 6 floors, cutting energy demand by up to 40%. With fewer internal columns, the building gains more open floor space, over 47,000 square meters, without sacrificing strength. Citigroup Center, completed in 1977. The Citigroup Center rises 279 meters tall with 59 floors, built directly above a historic church in Midtown Manhattan. To preserve the church, the building stands on 4 massive columns placed at the center of each side, not at the corners. This unconventional design redirected wind loads in ways engineers didn't fully anticipate. Later analysis revealed that quartering winds, hitting the building at 45 degrees, increased structural stress by up to 40% more than expected, risking progressive collapse. Engineers secretly installed welded steel reinforcements and added a 400-ton tuned mass damper, reducing sway by nearly 50%, all without evacuating the city.